A symbol of the growth of aviation, Orly is France's second largest airport, with 33 million passengers a year.
Paris-Orly is used by 30 or so airline companies with up to 350 departures a day and as many arrivals.
But today, the hub needs to adapt to an ever-growing number of passengers. To remain competitive and match the biggest European airports, Orly is being given a serious makeover.
It's a rebirth, a total renewal of Orly. We've reached the end of a vast renovation of the airport.
It was a massive challenge that you faced perhaps once in your career.
Over the past 4 years, all of the installations have been increased in size and modernized. A gigantic project costing more than €1 billion to turn Orly into a hub worthy of the 21st century. Starting with a new terminal, 250 meters long and 20 meters high, forming a junction between the two old terminals.
The biggest difficulty was constructing this 80,000 square meter building in such a restricted space.
But an even bigger challenge was for all these different transformations not to prevent Orly from functioning normally as an airport.
The ongoing work was designed to not block passenger access to the terminal and to allow the smooth running of the airport and air traffic.
A feat that the control tower also had to rise to. Thanks to virtual reality software, it underwent a total modernization in just 4 months, and without the slightest hindrance to air traffic control. That's some performance. The engineers took advantage of the work to improve airport security. Baggage scanning, firearm detectors, facial recognition passport control, state-of-the-art technology which tackles the growing threat of terrorism without passenger flow slowing down.
Security accounts for about 1/5 of the building's total surface area.
Security and fluidity on the surface, but also underground, where a new baggage handling system has been installed. A technological innovation capable of treating up to 3,600 suitcases an hour.
The baggage sorter will give us huge operational robustness and efficiency.
And Orly will need to be equally efficient in terms of accessibility if the transformation is to work. To make passenger access easier, the airport will soon be served by 2 metro lines, a first in France, which will make Orly more than ever a city airport.
We need to create space where we can build the metro station.
We'll vastly change the means of travel to reach the airport.
Get your boarding passes ready for the new Orly Airport. During peak hours, Orly handles 1 flight every 47 seconds, with no fewer than 100,000 passengers a day. All that 12 kilometers south of Paris, and with only 3 runways. But today, the airport needs to be reinvented. A major facelift, a gigantic worksite to give Orly a new look.
It's proof of our strong ambition to grow and modernize the airport's facilities, to elevate them to the highest international standards.
Hand in hand with Orly's massive makeover is a change of name.
We're saying goodbye to Orly South and Orly West. In the collective subconscious, this is a major change.
The new airport is simply called Paris-Orly. In the center of this new ensemble, Orly 3 forms the junction between the old terminals 1 and 2, now called Orly 1 and Orly 2 to the west, and Orly 4 to the south. The construction has produced a single terminal of almost 2 kilometers long. The brand new Orly 3 stretches over 80,000 square meters and is capable of receiving an extra 8 million passengers a year. This junction building is made up of 4,500 tons of steel and 9,500 square meters of glass. That's 4 times the surface area in glass of the Louvre Pyramid. The total cost of the operation, €450 million, an investment that has resulted in modernization unparalleled since the airport's opening 50 years ago.
The year 2019 will go down in the annals of the airport, with of course 1961, when the Orly South Terminal was inaugurated by Charles de Gaulle.
It was in the 1960s and 70s that Orly really took off.
La cérémonie d'aujourd'hui consacre l'aérogare d'Orly comme l'une des plus frappantes réalisations françaises.
With the incredible growth of mass transport in the years after World War II, Paris-Orly became in effect the birthplace of French commercial aviation.
Futuristic for its day, this glass and steel building became a showcase of French know-how. More than a main terminal, it was a town in its own right, which families visited on Sundays.
The people of Paris and its suburbs are very fond of Orly, notable for its viewing terraces, where thousands of them would gather every Sunday afternoon to watch the planes taking off.
In the late 1960s, more than 9 million people took off from Orly. But with the opening of Roissy-Charles de Gaulle in 1974, Orly lost its rank as France's #1 airport. The hub gradually became a sleeping beauty.
The Orly West and South terminals were suffering from an image of being old-fashioned and totally ill-adapted to today's airline companies.
The welcome zones, notably flight registration, were very small and extremely cramped.
Orly has also needed to adapt to the growth in air travel that's expected over the coming years.
Annual growth will be a regular 2% per year. That's an extra 600 to 700,000 passengers a year. So the junction building exists to assist with the growing number of air passengers.
In April 2015, the countdown started. The airport set itself 4 years to complete its makeover, and it would begin with the construction of the junction terminal Orly 3.
The biggest difficulty was constructing this 80,000 square meter building in such a restricted space. It was hemmed in on all sides by the 2 existing terminals, but also the parking lots and the tarmac.
And with a major challenge, no interruption of flights during the work. In addition, passengers were not to suffer from the impact of this vast construction site.
This building was constructed on the old parking lot, so for a certain amount of time, we had to handle flights farther out on the tarmac with shuttle buses for the passengers.
The first step in this vast renovation was to redesign access routes so that passengers could board their planes on time. New temporary roads were also laid to provide worksite access to trucks and machinery.
For the preparation work, we had to rethink all the access routes to the terminals.
There was one massive problem right in the middle of the construction site, this immense overpass. 52 meters long and almost 800 tons of concrete above the parking lot. To make room for the worksite, it had to be completely demolished.
We couldn't do as they usually do for overpasses and simply collapse it, because the parking lot ground wouldn't have been able to withstand the weight.
So we had to install a structure able to bear the weight of the overpass so that we could then cut it into sections.
The overpass was sliced up like a salami. The slices of concrete were then removed by a huge 800-ton crane.
Every night, the crane transported 5 or 6 loads of between 30 and 50 tons, so they could be broken up and loaded onto the trucks.
It was a difficult job that needed a lot of care and attention because we were breaking up concrete blocks weighing several tons.
A dangerous operation carried out when the airport was closed between 11:30 p.m. and 6 a.m. Only 6 nights were needed to demolish and remove the overpass's 19 blocks of concrete. Dismantling existing infrastructures, creating new access routes, constructing a brand new terminal. How could such a massive worksite not jeopardize airport security? The construction zone was particularly sensitive, so to securitize air traffic, numerous controls were deployed.
The closer you got to the airport, the tighter security became. There was a whole host of screenings to totally ensure that only the right people entered, only the right people were on site, and that nobody was carrying prohibited items such as weapons.
Here's one of the controls that everyone working inside the protected airport zone had to go through. Biometric badges, walk-through metal detectors. Each worker was scrupulously checked, along with the tools and vehicles.
We had a huge truck flow, especially when the work started, to bring in the structural elements, and large number of workers, with 500 to 600 of them permanently on site.
For these workers and their companies involved in the construction of the junction terminal, so many constraints could have become a nightmare. So a radical decision was taken.
We decided to place the site in the public zone to provide easier access for incoming materials and to avoid having to control the workers.
The borders of the security zone were shifted in order to exclude the construction site. And by not having to control the workers and vehicles, the work was kept within the delivery date. Here's what the zone of the future Orly 3 looked like before work started. The engineers had 4 years to construct the new terminal, and they made a daring choice.
We decided on a steel and glass building mainly for construction speed. With a fairly restricted delivery date, steel was one of the best solutions for rapid construction.
The junction terminal was one of the most difficult buildings to construct in terms of technical complexity, and it had to be done in a very short time.
The same building in concrete would have taken 1 year more, but steel or not, to assemble the gigantic erector set, cranes were indispensable. And as usual on the Orly site, nothing was easy.
The crane needed to shift the materials, due to the area in which it was operating, couldn't elevate any higher than 30, 35, 40 meters.
We couldn't use fixed tower cranes. We were forced to use mobile cranes, which can rapidly retract so as not to obstruct the air traffic control's tower's view.
With 700 takeoffs and landings a day, the control tower is Orly's nerve center. At the slightest malfunction, the whole airport must shut down. Without it, air traffic wouldn't be safe.
Like an air terminal, a control tower ages too. The tower's equipment needs to be regularly updated and modernized.
At 50 meters tall and standing out from all that surrounds it, the Orly control tower was in need of a complete overhaul. In November 2017, it would experience one of the trickiest periods of its life. Because how can you modernize a control tower without interfering with air traffic? Here's the control room that needed a makeover. From here, air traffic controllers have been keeping a close eye on the aerial ballet since the 1960s. 50 square meters of hullabaloo surrounded by 360 degrees of windows known in the jargon as the lookout.
Sur les 44 Papa Québec, ça sera Bravo 62 a priori qui va se libérer d'ici quelques minutes.
Running 285 bonjour, taxi by the left, Lima Romeo, stand Papa 12.
To keep the airport up and running, a temporary control room was needed 1 floor below. The trouble was, the space wasn't adapted.
We changed the exterior of the temporary control tower by inserting windows all around beneath the original lookout.
The old portholes were replaced by large windows to increase the controller's field of vision. But the most difficult task was moving the entire radar system, GPS and radio without interfering with air traffic control.
It involved a lot more than just unplugging, moving and plugging in again. It was much more complex than that, because we had to guarantee safety along with the continuity and regularity of flights. We couldn't turn up at 6 in the morning and say, oh, it's not working, so we won't open today.
After several nights of testing and tweaking, the move was finally completed and the controllers settled into their temporary lookout. Upstairs, the renovation of the old, obsolete control room could finally begin. Work continued day and night, taking maximum advantage of Orly's closure between 11:30 p.m. and 6 a.m.
It was a complex job because there were so many constraints concentrated into one small space. Technical constraints, time constraints, access constraints. Because we had to remove almost 35 tons of material and equipment from 45 meters up, then replace it all.
And the task was made even harder by the fact that the work could in no way endanger air safety.
One of our biggest fears was cutting through one of the radio wires, which are crucial to us. If a wire got cut, it would have compromised the opening of the landing and takeoff area at 6 a.m.
Over 4 months, the lookout was refurbished and equipped with state-of-the-art technology, starting with the soundproof ceilings installed to offer the controllers the most comfortable working conditions.
In the old lookout, there was a lot of reverberation and the controllers could overhear their colleagues. In the new lookout, we've improved the ambient sound. Subsequently, the individual exchanges with pilots are much more secure because there's no risk of being put off by your neighbor, and that improves concentration too.
New workstations were also created. Entirely digital, they can treat all the data of a particular flight. Airplane identification, its flight path, its altitude, and where it has come from.
The aim was to give controllers a workspace that's better adapted to new requirements, and to prepare them for the arrival of a new integrated air traffic control system, which can digitalize all the data of a flight from takeoff to landing.
To optimize this renovation, the engineers used the same virtual technology used in video games. Each controller could therefore test his or her future working environment.
We did a digital modeling of the entire lookout and used virtual reality headsets to plunge the controllers as soon as possible into their future working environment. That way, we could detect any problems and correct them upstream.
March 2017, the concrete screed had been laid on the steel structure of the junction terminal. Work could now begin on the interior layout. And to design it, the engineers turned to revolutionary software, which can model the new building in its entirety and anticipate the behaviors of future passengers.
The 3D mock-up enabled us to model the structural studies, along with those of passenger flows. We were able to walk around in this virtual mock-up to check all of the functional data and all of the architectural spaces.
To avoid past mistakes, Orly 3 is designed to evolve. What will the planes of the future look like? What will passenger expectations be? It's impossible to know right now. The only certainty is that the terminal will adapt.
An airport terminal needs to be flexible because human behaviors and technological progress are in a state of constant evolution.
We try to imagine what the terminal might look like in the future, so that we could give it the flexibility it will need to evolve and go on living.
Underground at Orly, another operation was also in need of a total modernization: baggage handling.
Orly's baggage handling system was really old generation.
We couldn't cope in the existing buildings. They were too cramped.
Deep within the brand new Orly 3 is a vast space entirely dedicated to baggage handling. Almost 10,000 square meters. That's larger than a football field, with a ceiling 7 meters from the ground.
We created a kind of cathedral, which contains state-of-the-art baggage sorting equipment.
It's very specific technology with a lot of motors driving it, and it transports baggage from registration right to the airplane.
Before entering this high-tech cathedral, baggage is recorded at registration and given a barcoded ticket. This contains all the information: flight number, final destination, and weight. Indispensable information for the correct transit of the baggage. Underground at Orly, the transit has only just begun. The system is composed of two immense 200-metre-long conveyor belts, seen here in red. These are the sorters, fitted with optical sensors capable of reading, in real time, the barcodes on the baggage labels.
The sorter guarantees that the suitcase is routed to the correct plane according to the destination contained in the label's barcode.
Once the barcode has been read, the suitcase is automatically tipped into the center of the baggage handling system, towards what are known as carousels. There are 12 carousels, seen here in blue. These conveyors allow the sorted suitcases to reach the containers, in yellow, which will transport them to the correct plane. The automated system has almost 4 kilometers of conveyor belts and can handle up to 3,600 bags an hour. A brand new system that costs €30 million, the price for turning Orly into one of Europe's top airports.
The baggage sorter will give us huge operational robustness and efficiency.
The system even avoids an interruption in the flow of baggage in the event of a breakdown. Backup conveyors are there to make sure suitcases keep arriving at their planes.
It's a bit like a powerful racing car, a Formula One car, for example. You have to learn how to tame it.
The only downside of this particularly sophisticated organisation is the high level of fine-tuning required. Before going operational, Orly carried out hundreds of test runs. In April 2019, for the first time, the airport carried out a full-scale real-life test. To make sure there were no hiccups, 4 airline companies and several hundred passengers were invited to put the new baggage handling system to the test.
No, we're still waiting for the green light from Air France. Today is like our big test flight, the last chance to check the robustness of our new system, from registration through to sorting.
That day, more than 1,500 suitcases were sent into the system.
We started preparing for the opening with our teams and airline companies more than a year in advance. We decided to bring the various companies into the new terminal little by little to avoid saturation.
But the operation would only be deemed a success once the baggage had passed through Orly 3's new security screening system, equipped with 7 tomographs.
We check all baggage with high-performance screening machines, and the volume of baggage is considerable.
Security is ensured by a number of machines that scan every case and bag heading for the holds of the aircraft. We need to ensure our hold baggage is 100% secure.
This new generation tomograph detects all kinds of dangerous materials. A technological gem worth €1 million.
It works like a CT scanner. It analyzes all the materials inside the baggage to identify the presence of explosives.
5 meters long and weighing several tons, the tomograph functions according to the principle of magnetic resonance imagery, which is used in hospitals. The rotating X-ray generator scans the baggage from all angles to identify the materials inside. A computer program then reconstructs a 3D image of the contents in real time. Next, an algorithm compares the threat with all the information on the explosive stored in its database. A block of Semtex, for instance, would show up yellow, like all organic materials, whereas a firearm, usually made of metal, would show up blue. Each item of baggage is dissected in this way in mere seconds. The new Orly tomographs screen 900 baggage items an hour.
The average transit time for baggage is 6 to 8 minutes. This can increase to 10 to 12 minutes, depending on the extra security checks that might be necessary.
Because if a suspect substance is detected, the baggage is immediately withdrawn from the system to undergo a more advanced inspection. The machines then make way for sniffer dogs trained to find explosives. This is the last level of inspection. The dog's sense of smell is infallible. But the major risk today is a terrorist attack. The Orly 3 building has been totally designed to be at the cutting edge of technology in terms of aviation security.
In the 1960s, there was zero security at Orly. There was no real reason for it.
The buildings weren't designed to integrate all of the new security equipment.
To meet the increasing security demands, new infrastructures have been installed at Orly 3 across almost 2,500 square meters. For boarding, all passengers must go through screening at border control posts, known at Orly as PIF zones.
Security occupies about a fifth of the terminal's total surface area.
In 2010, the depth of the PIF zones was 9 meters. Today, it's 28 meters.
Now, 6 people can be screened at the same time, compared to 1 with the old system. To check whether hand luggage contains explosives or firearms, each item is scanned. At the same time, passengers pass through metal detectors. If there's any doubt, the PIF zone is equipped with electromagnetic detectors, which screen your shoes without you having to take them off. Sample strips collect suspicious traces from your skin and clothes, which are then analysed chemically. The aim? To detect within seconds any components that may have been used to make a bomb or a chemical weapon. But the biggest innovation that has made Orly 3 ultra-high performance in security is the body scanner. These automatic machines are able to screen passengers from head to toe, and the results are far more advanced than the walk-through metal detectors. Body scanner technology works with millimetric radio waves. These pass through clothes and rebound off the body. Transmitters turn around the passenger and create a real-time 3D image. The screening takes only 3 seconds. The operator can therefore immediately detect any hidden objects, avoiding the need to hand search passengers.
It's less physically intrusive, and it provides a more precise level of detection.
While in the past 20 years, security has become the priority of airports like Orly, the PIF zones also meet another requirement: the smooth flow of passengers through the terminals.
Security dictates the whole organization of flow through the terminal and the passenger journey.
We've improved fluidity with this new generation of PIF zones.
Thanks to these new PIF zones, the full range of security checks lasts no longer than 10 minutes.
55 more passengers invited to proceed through gate 20H, please, immediately.
And Orly has also been equipped with new equipment for flights to foreign destinations. Fully automated gates permit the control of biometric passports in record time. More than 1 billion people worldwide already hold such passports. Identity photos and digital fingerprints are now stored on an undetectable and non-forgeable electronic chip. Invisible to the naked eye, it's also impossible to feel with your fingers, but it's there. Inside an inviolable page, more secure than a bank vault. It's this data that will be analysed by the technology in this brand new biometric passport control gates for foreign destinations. Step 1, the scanning of the biometric passport. The system identifies the passenger and connects to databases, such as that of the French National Police. Within 6 seconds, the authenticity of the passport is verified. The latest generation of automated gates, like those at Orly, even has facial recognition. Once inside the gate, several cameras take photos of the passenger, which are then compared to the passport's biometric data. A maximum 12 seconds are needed to pass border control, thanks to these sophisticated machines. But all of these security systems don't protect against what every airport fears most: a terrorist bomb attack inside the terminal, like the one at Brussels Airport in Belgium.
Passengers were wounded, not by the explosion itself, but by the environment, by which I mean the main walls and consequently the ceiling which collapsed on top of them.
To prevent such tragic consequences, the engineers and architects came up with an innovative solution.
Our ceilings are composed of various polycarbonate tubes. They're very light and also very bright and airy.
Were an explosion to occur, the shockwave would pass through the tubes, and even if one or two were to fall, no one would be seriously injured. But Orly 3 is also an immense glass cathedral composed of 9,500 square meters of windows. A possible death trap for passengers in the event of an explosion. But here too, technology has a solution to meet the safety challenge. And Orly turned to the very best. Based in northern Spain, this company specializes in high-tech glass. For Orly, it came up with ultra-resistant windows.
Basically, it's double glazing, 2 panes of glass held together, which allow the entire volume to remain stable and not produce dangerous shards that could harm passengers.
Safety, security, but also comfort. The new Orly operates 7 days a week, 365 days a year, summer and winter. And in summer, with the glass and steel architecture, the temperatures inside Orly 3 can soar.
In a steel and glass structure of this size, from season to season, it's very difficult to obtain the right temperature at the right time and the right ventilation at the right time inside the building.
Once again, the solution was found in the qualities of the glass.
We installed coated double glazing, which is ultra-high performance in terms of thermal control, so it tackles solar heat gain in the summer very well.
In April 2019, Orly 3 finally opened its doors. A brand new building of 200 meters in length, with 14 departure gates and all the latest equipment and fittings. And right in the middle, a work that passengers are sure to remember: a giant wall of water, 9.5 meters high, stretching out for 65 meters.
It's a real innovation for an airport like Orly. It's very beneficial as it creates calm. I think it might become Orly's emblem.
Passengers will remember Orly for its wall of water. It's a remarkable work, and there's nothing like it anywhere in the world.
It's in these conditions that the airport will welcome the 600,000 new passengers expected in 2020. But it would be impossible for Orly to reach this number without runways in perfect condition.
The runways are an airport's entrance and exit gates, and also an ultra-high safety zone.
With more passengers, we'll certainly have fuller planes, which will be heavier, and larger planes. This will have an effect on traffic and taxiing, and will create wear and tear on the infrastructure.
To host its expected 33 million passengers a year, Orly has 2 main runways: Runway 3 to the south and Runway 4, the most impressive, at 3,600 meters long. Despite an average of 630 flights a day, spread between 6 in the morning and 11:30 at night, Orly's runways hadn't been resurfaced for 10 years.
A runway has a shelf life. After a while, the landing surface starts to deteriorate.
Especially when it comes to wide-body jetliners like the Boeing 747 and 777, to which some professionals have given the unflattering nickname of runway killers. Here's what happens when a 400-ton aircraft lands at more than 250 kilometers an hour. With the repeated violence of the impacts, the surface suffers, and after a while, even the toughest pavement begins to crack. The result? Pieces of asphalt break off, and these can be extremely dangerous for the planes. So 4 times a day, the crews go out to inspect the runways. They only have a few minutes between 2 flights to spot cracks, holes, and other dangerous objects.
Inspection of runway 3 with 4 vehicles, 0624 inspection underway. A large hole, 30 to 40 centimeters across and very detrimental.
Curiously, in the summer of 2016, Orly decided to renovate runway 4.
Summer isn't the busiest period for Orly. Strangely, we have a very busy July, the month of August drops off, and then from the beginning of September to the end of October, we're extremely busy again.
But closing a runway must be a highly calculated decision because the consequences can be dire.
It means that throughout the work period, the traffic that's usually handled with 2 runways has to be handled with only 1.
We needed to calculate precisely how many flights a day we could handle on the remaining infrastructures.
And the first to feel the impact were the airline companies and surrounding residents.
It limited the number of takeoffs and landings, so there were fewer planes at the airport. For airline companies like ours, it basically meant delays for our passengers and difficulties in rotating our aircraft.
That's why the renovation was carried out at lightning speed, a mere 5 weeks to totally relay the surface. To construct a runway, firstly, a 1-meter thick base course of sand and gravel is laid. This is covered with a pavement of square concrete slabs, 40 centimeters thick. To withstand hundreds of tons, plane after plane, the concrete is reinforced with steel. And to prevent the aircraft from rebounding from this hard pavement, a further 30-centimeter layer of asphalt is laid as the final surface.
An airport runway is a very particular structure. It has a regulatory width, a length with touchdown and braking thresholds. You can't construct a runway any old how. It's more than a simple road.
The renovation of the 165,000 square meters of runway 4 could begin. The equivalent of 65 football fields. A gigantic work site involving 40 different companies. Almost 700 people toiled day and night. A meticulously planned job. The materials were even delivered long before work began to avoid any delays. But reconstructing a runway is more than renovating its structure. It also means renewing the pavement markings and installing a complex lighting system.
We need a system of markings and beacons, which would light up at night or in reduced visibility conditions to help pilots land more precisely.
Because all across an airport, markings and beacons are everywhere. To guide approaches, landings and takeoffs, but also during taxiing. So that pilots from all over the world can understand it, aviation markings and beacons are universal. The fluorescent markings indicate the axis of the runway and its distance. The touchdown zone is marked by these rows of white lines. Once landed, the craft must remain right over the center line, which guarantees that it will be perfectly aligned for braking. For safety reasons, the runway threshold is marked by a row of perpendicular red lights. A total of 220 kilometers of wiring and almost 2,000 beacons to change on this runway alone. That's an impressive number of light bulbs. So to prove itself as a 21st century airport that respects the environment, Orly took an important decision.
We integrated LED lighting, which makes big savings in terms of electricity consumption and also in terms of maintenance.
There's also the lighting for the landing assistance system, the most dangerous part of a flight. Orly took advantage of its makeover to install the very latest version.
We integrated a system, which we call PAPI. It's a runway visualization aid, which helps the pilot land in the best possible conditions.
PAPI is these 4 lights to the right of the runway. They indicate the altitudes to respect for a totally safe approach. That's the green plane. The aim is to have 2 red lights and 2 white. If the plane is too low, instead of 2 red lights, it will see 3 or even 4. A crucial indication that informs the pilot to pull back the throttle and make a new landing attempt in order to avoid a crash. Safety is not just the concern of the takeoff and landing zones. Between them and the apron, where the planes park, there are 30 kilometers of taxiways, with planes constantly circulating, a zone which needed enlarging and redeveloping. But the problem here was that under the asphalt is a network which is crucial to the smooth running of the airport. A network that the engineers took special care of during the work.
Aircraft are refueled via an underground network of pipelines.
Every year, 1.2 million cubic meters of kerosene are brought in from Le Havre and distributed by the pipelines that run beneath the entire airport. 15 kilometers of pipes crisscross under the tarmac, supplying the 90 parking places. With the addition of Orly 3, a dozen new refueling posts have been created. The trucks often seen under an airplane's wings aren't necessarily water tanks, but fuel trucks that filter and supply kerosene. It takes fewer than 10 minutes to pump in the 3,000 litres of kerosene needed for a Paris-Toulouse flight. That's like filling up your car in under 10 seconds. The other big challenge for Orly was being able to grow without increasing the disturbance for the nearby residents. Because the airport is only 12 kilometers from Paris and it's surrounded by an amazing urban density with 17 suburban districts and thousands of inhabitants. That's why, from the 1960s on, Orly has always interrupted traffic between 11:30 p.m. and 6 in the morning. Plus, the airport also uses only certain runways at certain times to minimize sound pollution.
Orly has 3 runways, but we run our daily operations on only 2 of them. We try not to use the north-south one because approaching planes must fly over an area with lots of nearby homes.
The north-south approach covers 4 suburbs: Créteil, Choisy-le-Roi, Orly, and Savigny-sur-Orge. Planes only use it when weather conditions impose it. Otherwise, the airport only uses runways 3 and 4. And as planes always take off into the wind, the direction of takeoffs and landings depend on the direction it's blowing from. Despite a nighttime curfew and a capping of air traffic, Orly has plenty of other disturbances to deal with.
Our air traffic control works together with the airline companies, studying possible modifications to approach paths and approach procedures. Things like if landing gear is released a little later, will it reduce noise pollution?
Not all disturbances are noise. There's also the air. In the Paris region, the pollution caused every day by air traffic is equivalent to that produced by 1 million road vehicles.
The objective is simple, to reduce the fuel consumption of aircrafts on the tarmac during approach and on takeoff. This will allow airports like Orly to grow within an urban environment. In fact, today, it's their only option if they want to continue to grow.
To help the hub reach its objective, engineers have come up with a stunning solution, OptiClimb. This technological innovation is a revolution in fuel consumption management. Type of aircraft, weather conditions, flight path, the software draws on an incredible amount of data.
We compiled millions of flight hours and inserted them into a machine learning software in order to optimize flight paths.
The result, whereas before takeoff trajectories were standardized for all aircraft, whatever their weight, now OptiClimb establishes a customized route for each individual takeoff. By making comparisons with previous takeoffs, the software offers the pilot the best possible climbing angle and the most economic engine RPM. The plane reaches its cruising altitude, having emitted 5 to 6% fewer greenhouse gases and having created less noise.
It's like energy-efficient driving for cars, but applied to aviation, and it's the pilot who uses the software's recommendation.
Another problem is that planes also pollute a lot while taxiing because their engines are not designed to drive. So Orly has created an innovative solution called GLD, a local departure control system.
Together with air traffic control, we developed a program to optimize the taxiing of aircraft on the ground.
One example is being able to prevent aircraft from waiting stationary at the runway threshold before takeoff.
By making the plane's journey from departure gate to runway, the new software also makes pre-takeoff time savings. This too decreases pollution.
We can now ensure a much shorter or even non-existent waiting time at the runway threshold before takeoff. This is very different than what you can observe in some countries, notably in the United States, where during peak hours, the aircraft are waiting in lines. At Orly, that doesn't happen.
In that way, several thousand fewer tons of kerosene are consumed each year. And that also means tens of thousands fewer tons of CO2 being released into the air.
Airline companies estimate savings of 8% on fuel per year. For Orly, that's a considerable reduction in its ecological footprint. Safe, secure, comfortable, greener. For its passage into the 21st century, Orly must also become more connected to the centre of Paris. Whereas these days, 80% of passengers arrive by road, in 2024, a metro line will drop them off at the foot of their planes, a first in France.
We can't wait for the opening of the Greater Paris Station in 2024, which will put Orly at only 20 minutes from the center of Paris. That will relieve the traffic that builds up on the airport's roads during peak hours.
Will vastly change the way that Parisians and suburbanites reach the airport. Access to the airport will then be greatly improved.
But to reach the new station, the metro will have to pass beneath a new Orly 3 building. To make sure it doesn't collapse during the work, the engineers have come up with some very special foundations.
We calculated and dimensioned the foundations so that they can be bored through and still maintain the terminal's rigidity and solidity.
The building's resistance is provided by 400 immense concrete piles, some of which are driven into a depth of 33 meters. At the point where the metro will pass, reinforced walls have been installed and covered with a concrete platform. This allows the tunnel boring machine to operate without weakening the entire building. But for trains to stop, Orly will need to build a station. And it will be bang in the middle of the airport.
It's open-heart surgery, because we need to create space where we can build the metro station.
The work has just begun with an enormous 35-meter deep hole. On completion in a few years' time, the station will become a metro terminus. After 4 years of work and €1 billion invested, Orly has given itself a new start. More than a renovation, it's a revolution.
An airport is always evolving. So it's our job as airport managers to anticipate future needs and to update it in order to meet the new demands of both passengers and the airline companies.
This giant project has proved impressive, with runways now equipped with cutting-edge safety solutions, a control tower totally redesigned to handle increasing air traffic, and at the heart of the new Orly, a brand new terminal, which rose from the ground in record time. A technical and technological feat, the completed work is also a story of men and women, all fascinated by this mythical airport that continues to nourish the dreams of generations of passengers.